Sure.
Tested.
Yes. Hmm?
So, welcome participants to our final day, day 6 of AETSEC ATAL-FDP workshop hosted by IIIT Kottayam. So, today, as the first speaker, we have Dr. Parvati. Dr. Parvati works as a battery specialist at Daimler Trucks AG, steering cell development and battery aging. Parvati completed her PhD from Karlsruhe Institute of Technology, KIT, Germany, in the field of printed lithium-ion battery electrodes. She finished her master's MS from IIT Madras, Chennai. She is an interdisciplinary electrical engineer with expertise in battery hardware development. She began her career at UL International GmbH, Frankfurt, gaining avid experience in IEC, UL battery testing, and functional safety. She possesses excellent interpersonal skills and wide array of speaking experience, including individual training and group lecturing. With outstanding adaptability, she has worked with international team members across the globe. She has been actively involved at promoting battery safety and authored various international journal articles. We welcome you, Dr. Parvati Sukurji, to this workshop.
All right. Thanks for the kind introduction, Dr. Ella. So I would like to welcome the audience to my talk. So I will be delivering a short overview about the application of AI innovations in transportation, and especially focusing on the second life of aged batteries. So you have already heard about myself. So short intro. I am currently located in southern part of Germany, and I'm originally from Kerala. I'm from nearby Kochi, Alava. The town name is Alava, and I did my bachelor's in electronics and master's from Chennai in engineering design, and my specialization expertise is in batteries. So currently, I am performing battery simulations for the electric and fuel cell trucks within Daimler Truck. Daimler Truck is mainly an electrified truck company, and I will provide more portfolio about the product management and what are the processes for the new battery pack designs, and also how our market is defined in the European and US market. So we are one of the largest manufacturers of trucks, and we have a lot of sister brands named Cetra, and we recently acquired a company named Brizon and Freightliner and Western Star for US, and for school buses and Fuso for the Asian Japan market and the Chinese market, and Bharat Benz for India. So we have a large portfolio of the vehicles, especially in the heavy duty vehicles. So we arrive from the company of Mercedes, and we have separated from the parent company from 2021 December and onwards, and we are known as Mercedes-Benz Trucks or Daimler Trucks in general, with our financial services as a backbone as well. So these are the passenger cars. This is an EQS, which is electrified S-Class. So our strategy for the company is about, yes, we need electrified drives. So electrification can be done in two ways. The first would be with the electrified motors powered by battery. And the second would be the electrified motors powered by hydrogen technology, or in general fuel cell technology. So only these two can give a carbon neutral friendly propulsion strategy for the next future that awaits us. So one of the major, or few of the major truck portfolios I would love to introduce with you. So first one is Gen 2 hydrogen truck, and eActros 600 is our popular model in Europe, and our eActros for the smaller version, and Canter for the smaller vehicles payload. So as you could see, of course, the hydrogen trucks, they can carry more load and more distance, let's say 1,000 kilometers in one hydrogen refill sessions. But the battery trucks, they will go for lighter loads. So the maximum will be 40 tons, 37 tons, something like that. And for shorter distance, let's say 500 to 600 kilometers. You can ask questions in between during the slides. Please interrupt me if I'm too fast or if you have any doubts or queries. So our main ambition is, of course, to have the carbon neutral transportation by 2039, as per the rules and regulations put forward by all over the world countries. So we have portfolio from the school buses, Thomas Bell buses, to Freightliners, and these are the European models and the buses. So ECR is one of the popular model in Europe and also in Germany specifically, and Econic is for the waste trucks, and Freightliner, these are for the shorter trucks, let's say for the Amazon pickup trucks or for DHL postal services. And we also offer charges for the developments in Turkey and many of the European countries as well. And Fuso, it's the popular model in Japan. So of course, the region-wise, the customer experience also delivers. It differs from wholesale market to finance and the leasing market, depending upon the customer review. So our strategy is to have a connected world and by use of modern technologies to lead profitability and to lead transformation. And trucks, as you can know, they are the backbone of any transportation systems because we need items to be delivered all over country or all over the world. And we have delivered more over 27 trillion kilometers of goods. These are transported every year from short distance, whether long distance, we have the portfolio covered. So for any of these factors for transportation, we need that we have to have many product offerings for the customers. And of course, when we have electric trucks, we need to see how the infrastructure is well developed as in terms of charging station, the grid development, and of course, we have to keep the cost in a competitive range so that the customers will appraise us there, thereby leading to our acceptance. So it's a CO2 neutral transportation is like a few multiplication process. It's not very easy. We have to give a win-win solution for all of the parties. So we have the strong brands in across the world, also in India in terms of school buses and the short-term payload trucks. Our software development center is located in Bangalore and nearby Whitefield. So, and also we have close collaboration with IISc Bangalore and also the IIT Hyderabad, yes. So, having told about a brief outline about the truck industry, I would like to give a summary outline about my talk today. So, firstly, I will brush up the basics of lithium-ion batteries, and then coming to the safety aspects, how thermal propagation is going on, and also the safety and performance aspect, coming to the final discussion points, which is our second life of batteries, and how the applications of AI in transportation is possible. So batteries are quite important to us, and just think about how many lithium-ion batteries are within like 5 feet. Now we are in the online presence, but our laptops, our headsets, our mobile phones, our iPads, everything needs battery. So that means batteries are inevitable for our daily life. So the battery journey started when there was a prominent innovation from Sony in 1991 in terms of uh, the intercalation battery named of lithium cobalt oxide. So in this case, I will explain the basics of the battery here. So lithium, this side is called as cathode and this side is called as anode. Cathode is usually lithium containing compounds, maybe oxides or metals, and anode is usually carbon based on graphite materials. So this will give the electronic conductivity and lithium will give the ionic conductivity. So the lithium from here will travel across the electrolyte, which is a conducting medium for that. So usually it will be lithium containing salts like LiFePF6 or some carbonated solvents. And of course, due to the lithium ionic mobility, we get electronic mobility on the other side, which is our electric vehicles, the lights, or any other loads that we put. So, of course, there are different chemical structures for the cathode materials, like a layered structure, or which we will revisit in the next slides. There will be no amount of water-based electrolyte used for this kind of chemistries. So, of course, it is all based on oxidation and reduction reactions. And this part of it was awarded the Nobel Prize, as you already know, in 2019 for the three excellent scientists, Professor Goodenough, and also Akiro Ishino. So it's a sandwich structure battery in general. I hope it's clear for all of the audience. So when you have the kind of three-layer structure, this could be arranged in three types of design. And this is called as various cell design formats. And depending upon the application, we try to use a specific cell for that application, depending upon the voltage requirement, current requirement, and also the safety. So these are the three important factors. So as you could see, this is an cross-section diagram, 3D diagram for the or an electric truck. So usually the batteries are kept on the ground compartment closer to the axles, and there's a central line connecting the all the six wheel drives. So it's a 6x2 axle drives. So there is a powertrain controlling it. So this battery pack, when you magnify, it looks like various compartments, and each of it will be made of some call as cells. So cell, module, and pack. These are the three levels of battery. So let me walk you through what are the cell formats available. So cylindrical cell, these are the typical cells that we see um, in our clocks or electronic toys. It's easier to manufacture, and it's quite strong. Even if you put it down, yes, it's quite strong for any rupture. But it is heavy because of the metal case, and it's not very nice for the multicellular packs. But Tesla vehicles, electric vehicles, they use for their cars mostly cylindrical cells. For the trucks, we need more energy. So that means we need more amount of material. So we use primarily prismatic cells. They are like power bank designs. They have more space and more active materials you loaded to it. But of course, it's expensive for the manufacturing because of the casing and the covers, but it offers more offers more safety mechanisms. And this pouch cell is kind of like a coffee bean bag. However, since the area is more open, it's more prominent to environmental conditions, like if it is very hot. And these are mainly used for the cells which are localized and tested in the research and development laboratories. So this format is mainly for the trucks, and cell format is mainly for the passenger cars. Please interrupt me if there are any questions, okay? So let's visit some of the main battery properties. So the first one I would love to explain to you is battery properties, and the application scenario is defined by various factors. Of course, the battery suitability has to be decided with which type of material chemistry. So lithium, nickel, manganese, or cobalt oxide, lithium iron phosphate, or solid state batteries. So the main battery property that we have to consider is, of course, cost should be less. That is all of our dream. Sustainability, it should be having less carbon footprint, and it should be safer because it shouldn't explode, and it should deliver enough power and energy density, and it should last for longer lifetime. So all of the batteries, they are like humans. They don't like much higher temperature or higher discharge rates or voltage. So for batteries are quite sensitive to the environment in terms of temperature and voltage. When you tell about batteries, instead of the different format, there are different types of batteries as well for applications. For example, if we have a glucose sensor and it needs to be applied to our body, then we need some kind of flexible batteries. And here we use lithium polymer battery for that application. So this lithium ion battery is the main one that we are discussing. So this is used for all of the applications which I will be discussing in the next slides. And lithium metal is also used for certain applications. For example, Panasonic ones here. When we tell about batteries, there are different terms that is concerned with the battery. So first we will learn the basic fundamentals of the batteries. What are the terms and the conditions that the battery should be operated, and then revisit the safety components. So whenever you hear about battery, there will be some kind of terms called as capacity, rated capacity in ampere hours. So that means how much is the actual energy that we could be given by the battery, which is at the play field of the batteries. And whenever you say the battery is 100% charged, you will have how much energy is stored in that battery. So 100% SOC means 100% charge, and 0% SOC means it's fully discharged. So it's a state of charge of the battery at that moment. So, as I have explained before, there are different battery chemistries, namely NMC, LFP, and lithium polymer batteries, or these are also known as solid state batteries. So here we have, in these two, we have liquid type of electrolyte. This is not based on water, but non-aqueous based. And in this solid state batteries, the electrolyte will be a lithium conductive polymers. So that means it's quite solid, but this will provide more safety because it will not flow out during the operation or any safety risk conditions are there. So solid electrolyte, they are more safer. So that means we don't require any more separators, films or membranes like that. They provide more higher energy density because the anode is usually metallic lithium. The only demerit of solid state batteries, these are that they require every time temperature stabilization. So in order for this solid state electrolyte to activate, we need a temperature of between 80 degrees Celsius to 100. So the battery should be always hot. Yeah. And there are different companies which produces it for the electric buses in Germany, lithium polymer or LMP. These are from France. We import it from France, one of the startup companies, and we utilize in our electric buses, especially e-Citaros and the freight buses for airports. So, coming to the energy aspects of the battery, so I would say capacity in ampere hours, which I have explained about in the previous slide. So, that is the amount of electrical charge that could be delivered by a 100% fully charged battery. And of course, we need watt hours, how much energy can be taken out of the battery, which will be the capacity multiplied by voltage. And these values will be the rated values given by the suppliers. Usually the suppliers we have, they are from all over from Asia and also from US and from North Icelandic countries as well. So for example, Northvolt in Sweden. So they provide the nominal values for it. Whenever we have a battery, of course, when we are using it in an automobile, so that means there should be some tolerance ranges and some sort of safety aspect that is defined by the software. And they will be range how much amount of battery could be used, because suppose that our battery vehicles are running in a very high speed lane and it comes to a stop because the battery is depleted completely. So this should not happen, and we need the safety to be ensured that once it reaches 20% of its capacity, it gives a warning, and 10% it has an emergency shutdown. So the energy can also be defined in terms of volume per pack and also in terms of gravimetric terms in terms of kilograms of capacity. So this would be better if we want to define different battery technology. Other than lithium, there are many competitive technology called the sodium-based batteries or lithium sulfur-based battery. So we need an absolute value, and volumetric and gravimetric provides this aspect. So the next would be the lifetime of the batteries. So this is an important aspect because we are studying today about the aging of lithium ion batteries. So today we have the lifetime, um, which is defined in terms of state of health, in short, SOH. SOH is usually measured in percentage. That is the rated capacity from the manufacturer, which is, and the current state, that is the capacity measured. So when you say that the battery is just produced, that means it's 100% state of health, it's fresh battery. But when there is 20% capacity loss, then we say that it's only 80% of it. And as per the rules of automobile industry, especially ECR 100 and the UN safety rules, once the battery reaches 80% SOH, we have to refrain from using in high critical automobile applications and running in the roads. Yeah, so that is why we have to think about second life of batteries. So when you say about aging, of course, when the battery electric vehicles are operated, so the first part will be during the driving, they will be subjected to aging process because we are discharging the battery and we are discharging the battery during the driving session and charging the battery in an electric vehicle charging station. So all of this usage, like multiple charge and discharge, this chemistry will change over the time. The lithium ion mobility will change, and this term is called as cyclic aging part. And of course, the temperature influence will be there because I'm located in Germany, so that means winter here is extreme. The temperature can go down even to -7 degrees Celsius, and in summer it can go up to 30 degrees Celsius. So that's a very high fluctuation rate. So that means the batteries are prone to the temperature, even though they are encased in a package and everything. It will have an influence about the ambient environment. The next one would be calendaric aging. This is a term that means that when the battery is produced, it will be kept in a warehouse. And this process can also lead to the degradation of the cell, independent of whether the battery is used for automobile application, for driving or any applications, or even during the parking time, the batteries are degraded. So let's revisit what are the applications or what are the main factors that decreases the lifetime. So the cell temperature, as I mentioned, and what is the depth of discharge is a term when we continuously try to ramp up with the limits of the range, and then it will cause higher influence in the aging aspects. And whenever we try to overcharge, over discharge, then it will affect also the lifetime of the battery. And when we do fast charging multiple times over the day, that also influence to the degradation of the battery. I hope this until this slide is clear for the audience. If there are any questions, please revert me back. Yeah.
I think they may ask question towards the end, okay, Parvati?
I say, all right, yeah, then sure,
Towards
sure.
the end, you can give 15 minutes or 20 minutes. Yeah.
Sure, for sure. Yes, yeah. We do it like that, yes. Okay, so we have revisited the battery aspects until now, and not all batteries are the same because we need batteries specific for each of the applications. So for example, you can say a passenger car. And at the right side, you can see an electric truck. Of course, the range is different. For passenger cars, we have very limited installation space because we have only the trunk and behind of the passenger seating, below the passenger seating. So that means we need more batteries, more range, but less space. For the trucks, the main requirement is the based on the consumer because most of the consumers require, okay, we need more transportation to be placed or more things to be transported, so more payload, that term, and also we need more range. So typically the truck drivers in Europe, as per the rules, they are required to have a break after 3 hours of continuous driving. So that is why we are aiming more or less 500 kilometers range. So When you compare the metrics and the numbers for the cars and the heavy duty vehicles, of course, the car mass is very less, but trucks, it can go up to many tons. And the range of kilometers we are looking is 1.2 billion kilometers. However, for the cars, there are different warranty conditions, like 300,000, 400,000 maximum for 4 years, because it depends on the individual driver. So we can design the warranty condition as per the customer as well. So the charging duration is very different for the cars. It needs means our cars are very fast, should be charged in a time where we get some coffee or so. But the trucks, the payload time we require, that is even stricter because the trucks needs more distance, so lesser time in the charging. So it's a win-win condition, but these are the two different aspects of automobiles, heavy duty and medium size. Of course, when we consider about trucks, they are quite big. So the truck batteries are also big, as you can imagine, as per from the car batteries. So the car, the amount of kilometers driven by the vehicles from long class of the trucks to medium-sized trucks, buses, they are mostly driven in cities and in between cities like intercity buses and the delivery truck that we have from DHL, Amazon also, these are shorter distance and the cars even lesser. So there are many competitors for us, MAN, Scania, Volvo, DAF. These are mainly the players in European market. And of course, in India, the market is different. So anyways, we need to reduce the carbon footprint and we will provide it because the trucks drive more kilometers per year than the car, and this will be more effective. So we have revisited earlier the different chemistries for the batteries and different formats. So let's have a comparison for it. So all of this is based on the type of amount of cost that is given by the customer, how much they can afford, and also how much should be the C rates and the faster charging rates. So higher C rates means we go for NMC-based cathode materials, and for safety means we go for LFP. Most of the Chinese manufacturers are mostly concentrated in LFP-based chemistry, and in Europe, it's mixture of both of it mostly. So as you could see, so the cells are the backbone, and we convert and stack it to the battery module, and then we stack it completely to a battery pack and enclose it in a plastic case. So we have learned about the good things about batteries until now. Of course, there are quite a bit of safety concerns with the lithium-ion batteries as well. So as you could see, some of the cylindrical battery cells can actually spill the electrolyte. These are corrosive, so it's harmful for us. It's acidic in nature. And also there are some lithium metals which could grow and short circuited and thereby causing some explosions. This is one of the explosion which happened in 2021 in southern part of Germany because one of the diesel truck got in fire and all of our 15 buses got into explosion. This one recently in France, and this is one of the swelling of the pouch format cell, and this one happened in South Korea recently. So all of these will have kind of impact on the safety concern for the lithium-ion batteries, all of these accidents. So that means we need to provide them protection. So in the next slide, the previous slide, we talked about the accidents that could be caused. So what are the reasons for that accidents to occur? So the main causes are electrically, we try to overcharge or over discharge, or thermally, if the temperature fluctuations are too high during the use, or when we mechanically abuse. If somebody tries to penetrate the battery or sometimes drop the battery, then internally, unfortunately, this could not be avoided, some short circuit mechanisms. Of course, there are many testing activities which could replicate this kind of phenomena, and this is what all the automobile manufacturers use. So they try to do all the mechanical, electric, and thermal abuse tests, and thereby studying the safety aspects of battery. So Always operate the battery in a safe, normal area that is specified by the manufacturers. And over the voltage range, of course, single cells means 2.5 to 4.2, and depending upon the temperature range that you are supposed to operate. Once it reaches the damage area, of course, the composition of the material changes and the structural changes happen. And of course, there will be an exothermic chemical reaction. This details we will deal it in the next slide. So when there is a temperature fluctuation, it is like a cyclic chemical reaction. So that means as you could see here, suppose that this one cell is having voltage or current or thermal fluctuation. Thereby, it will cause ineffectively temperature rise and the chemical composition will change in the atomic level, and there will be exothermic reaction. That means heat is generated. The heat will be dissipated at some point, but then again the heat will is generated. And of course, there will be some software warnings for it in the early warning. If there is only one cell, we could somehow complete it by turning off or the safety mechanism. But if multiple cells are affected, unfortunately, it's like a chain reaction. This will continue no amount of what safety mechanism is it. So that means we need to have different levels of safety mechanism in cell and in module and also in the pack and system level. System level is means vehicle level. So we have seen the various cell formats previously, such as cylindrical, pouch cell, and prismatic cells. So there are various tabs on the top of it, and also the heat dissipation mechanisms and current interruption devices for the various cell formats. So there are many safety strategies, actively and passively. So passively means we can use a resisting component to dissipate the heat. So sometimes the manufacturers, they use the brake resistor, which is our resistance, to dissipate some of the energy. And active strategies means we use always thermal management softwares, battery diagnostic softwares, and monitoring softwares. And thereby, this gives more efficient warning and early state estimation of it to the user, that whoever is driving the vehicle. So all of these concerns should be addressed, and we need more amount of research and development activities for it, especially to the aging and production mechanisms. And also we need new battery materials as innovative methods. And we also require that, of course, thermally how the batteries are behaving during the chemical reaction. So lithium and battery safety could be engineered by more better efficient materials, better battery materials, better softwares. And the brain of the battery is battery management system, which we will revisit in the next upcoming slides. And these, in general, these are the battery safety risk hazards. All right. When you say the batteries are important for each and every applications, so there are many test and development activities behind it. So we need to identify which is a better battery for our application. So I am coming from an automobile field. So that means the individual cells need to be evaluated for their electrical suitability, its temperature suitability, and also abuse tests are also known as negative tests. So these are like above operating the normal window and finding the safety aspect. So all the batteries, the cells, these are individual ones. This will be stacked together to have a module, and modules are stacked together to have have the battery packs. And there is individual battery management system, in short BMS, and these BMS will control the range, the operating window, and also the early warning signs for the user. And all of these batteries, so for the trucks or any electric vehicles, we require multiple battery packs to be stacked together because the energy requirement is quite higher. And in general, of course, we need to also see how much environmental stability we could provide with the battery, and we need longer lifetime, so aging should be reduced. So accordingly, we have to test depending upon the applications. So safety could begin from the material level, which is our chemical levels, and evaluating of their the flammability, the toxicity of the chemicals, and what are the best anode and cathode materials. And in the cell level, we could see that this is an example of a cylindrical cell. So there will be some kind of tabs on the top of it to have a cell level safety. But module and pack level means all of these are stacked together. So if one of them goes into thermal runaway, there are chances that this fire can go to another compartment. So this should be avoided. And this is the most critical aspect for all the automobile industry. For the electrification, we need safety design. So, as a first part wrap up, I would love to give you a conclusion. We have studied the basics of the battery. So, we have revisited what are the safety hazards and how we could select the best battery material depending upon our application, and also how to improve the safety of the batteries. So, these are the chemical phenomena which happens during when the battery is subjected to high temperature, and there is heat accumulation and then explosion. So these are the chemical reactions on the different stages when they undergo thermal runaway. And we have revisited the terms of the battery, namely different battery definitions. All right, so next let's go back to the environmental impact of the battery. So we have different types of battery techniques, like battery manufacturing techniques, such as based on chemicals, water-based, and without the need of any solvents. There are also dry coating method. Tesla batteries, they mainly are made of dry coating methods, and we need all of these steps. We need expert input and also quality control, because the materials has to be shipped from all over the world. As you know, battery materials is shipped from mainly from China, from Australia for lithium, from Chile. So we need logistics to control. So best quality control shall be processed. And also we need the data for our critical parameters, because battery has to be operated at certain safety conditions. And all of this requires data. And this thereby here we require artificial intelligence and all machine learning algorithms in this part. So even in logistics, warehouse, and also in production, we have to use all the data analytics part. So for any production unit, instead of producing hundreds and millions of as investments, we first need to analyze how the production unit will come in terms of a twinning of it. So we make a digital twin of any of the batteries based on the modeling aspects, the lab data which we previously tested, and we will also have the field data from the vehicles which are currently in the road. And based on machine learning and algorithms, we try to predict what might be the effect for 10 years, 20 years, and how much lifetime could we use this battery safely. And in case when this battery should be shut down from the roads for due to the safety aspects. So the system design, the complete vehicle design has impact on this whole service life and also the service overall performance of the battery. So these are the main factors which will provide us information about the battery lifetime. So we have revisited the basics of the battery and how it is important. So the batteries could come from the different chemical materials, the chemical components, to the cells and pack, and then to the application. Whether it is for the airplane or for small lead scooters or for long haul trucks, we need all the safety aspects and we need the data analytics as a backbone for it. So talking about safety, we have previously visited the batteries has to be operated at certain conditions. So that needs a software control. And battery management system is a master brain of the battery. So this, as you could see, there's an example of the battery which is seriously connected. So there are different types of batteries, and this will be monitored for the state, current state, how much is the charge? For example, 100% charge, 50% charge. So sometimes this battery, as an example, it will be 80%. However, this battery will be 90%. So we need to equalize each of the batteries. And this is called as cell balancing techniques. So in addition, we need also to have the protection mechanisms and thereby sensing what are the overcurrents or short circuit currents. And this will be controlled, of course, by microcontroller or microprocessor based systems. And this provides outside information to the user and to the dashboard whether the battery is overcharged, over discharged, if there's any error, and to the pack level communication as well. So we need safety aspects from the battery management or BMS in general, and also the performance. The performance window, its operating window should not be violated. And also we need to monitor the aging in terms of the state of health. That is done by the diagnostic softwares, which is also included in the BMS. So BMS monitoring is very important in the every aspect. So we have different BMS manufacturers, and they have data acquisition rate of about milliseconds to even microsecond for certain applications. And of course, when we are charging the batteries, we will actively monitor it and balance for each of the state of charge and make it uniform so that the battery can perform in an optimal range. All right, so in a circular economy, means that the battery, once it is produced, can be used as a first in the electric vehicles. So artificial intelligence is a backbone for controlling how the battery works. And also when there is power that is delivered from solar, wind, or any of this charging, we need the power quality to be uniform for all of the users. So that means AI comes to and help for it. This also helps in understanding about the aging of the battery, what are the optimal driving conditions, and how to reduce the footprint of the battery in general during its operation. So whenever we need, when we make a battery, it's not only that we make a component just to dump. So that means we also need the batteries to be repurposed for the second life. Repurposing means once the battery has reached, let's say, the end of life, so let's say approximately 80% of the state of health, this will be taken out and can be used for some other application like energy storage application. And some of the cells could be used for some of the not critical applications in home appliances. So this is called as refurbishing. And in the end, if the batteries are no longer usable, then it can be recycled in collecting the individual components. So all of this part we will revisit in the next slides. So how is circular economy working? So first we have, this is the part I'm working in the battery design and research and development. We will give all of our findings to the production units where we have a lot of raw materials collected all over the world with the logistics, and we produce the batteries. And then we use in the first life, which is our vehicles. For my case, it's trucks or passenger cars. And then after it reaches certain amount of time, then it can be used for second life applications. Once it reaches the retirement time, which is 80% of the state of health, then it can be remanufactured or in short reman. It can be stored for the use in energy storage application, or it can be recycled. So let's revisit. So the recycling processes look like this, and the resources are mostly lithium, manganese, cobalt, nickel, etc. So all of this requires data collection and model-based prediction based on experimental testing data. So what do you mean by second life for the batteries? As you can imagine, the battery is a very large contributor for the commercial sector in any industry. So there are a lot of electric vehicles produced over the time. And these batteries, once it reaches, let's say 5 years or 10 years, it can no longer be used in this kind of vehicles because of the safety. So once it reaches 80%, this is end of life use in a car or in any electric vehicle. So the second life would be taking the batteries and to be used in storing the energy. As an example, from solar systems. So when solar systems are operated, we need a battery to store the energy. When wind turbines are operated, we need a battery to store the energy. So this second life of this the electric car batteries could be in the energy storage system or in general battery energy storage systems. And in the end of life, this also has some end of life conditions, of course, when the battery is no longer safe, once it reaches approximately 30% or 40% each, then the battery could be recycled and collecting again the constitutional materials. So all of these vehicles will be reaching the end of life sooner or later in a couple of years. So we will be dealing the second life batteries soon as an important topic. So we have know about, we are pretty aware that, of course, the batteries, once it reaches end of life, has to be recycled. So sorry, the slide is in bit German. The battery modules, once it reaches the end of life, they will be taken, they will be demounted, and it will be collected, and it will be subjected to many hydrometallurgical processes, and the sorting will be done. And in general, after the processes, we will receive a black mass. The black color is mainly due to the carbon, which is graphite in terms of it. And we try to collect by means of solvent extraction the metals, which is the precious metal like lithium, nickel, cobalt, manganese. And there are also aluminum and copper, which are the two electrodes which are coated. And we could also find the global metal demands. This is rising over the years, and we don't have this much amount of materials available in the world or in earth in general, and we need to reduce the amount of mining activities because it's so much of environmental exploitation. And this could give rise to the circular economy, that thereby replenishing the demand for these all precious metals. Of course, we need to identify the purity of the recovered materials. It should be more pure because the batteries need pure chemical materials. So the main byproducts will be, of course, metallic aluminum, copper, and also iron, depending upon the manufacturing process, and in general, the plastic materials because the casing is made of plastics. All right. Coming to the final and part of our topic. So how the applications of AI in transportation is happening. So as you know that, of course, there are various types of vehicles from ranging from long haul trucks to cars to the buses to small autos, electric autos. So for any of it, we require a lot of data management and machine learning and process control. Yeah. So as you could see, there are a lot of literature contributions how requiring the use of application of AI to the energy storage system for electric vehicles. So it's a lot. The 2024 is still rising, and it will be more, even more. So the main aspects of revolutionizing the transportation industry is autonomous vehicles, where autonomous driving is more carried out in certain countries, depending upon the regulations, and also for the smart parking systems. And we have to optimize our supply chain, as you have seen from the last years of Corona, how our supply chains could be optimized, and how it is a critical factor in each and every manufacturer case. And of course, the data can be used for predicting maintenance of the vehicles and how much is the service warranty and guarantee condition, and how effectively we could use our public transportations for the fleet management and also smart traffic management. And in the next slides, we will revisit all of these aspects. So every day, the battery generates gigabytes of data, whether from the battery health state or from the vehicle state, from the surrounding environment. We have a lot of data from electric vehicles. So if we exploit it nicely, we can predict about the future and the maintenance of that electric vehicle. So of course, when there is a lot of energy coming from the grid activities, the power quality could be detected, and this could be very much effective for sharing the amount of charge to the different application, namely charging station or stationary storage systems or power plants, or even to the industries. So AI methods could control the electric power systems, even for the generation and perfect optimization of the wind and solar powers. Due to the nonlinear behavior, of course, power quality could also be difficult because of the harmonic distortions. So AI could also give a very good idea and optimization the power quality. And comparing to the vehicle to grid applications, of course, when the power plants are producing, or even when our in-house solar plants are producing a lot of energy or electricity in general, then we can give back to the grid, and this can also be let's say applied by means of AI. So coming to the charging mechanisms, the charging systems could also be controlled by means of a dynamic pricing, by means of the power grid. We can give it to the power grid or based on the household demands or from the renewable energy. So we are indirectly control everything. There are many aspects for the AI for the vehicle to grid applications. If there are specific questions, I would love to take it in the end of the discussions. So, the important application of AI in the automobile field is the autonomous driving assistance system, or in general, ADAS. So, we have a close collaboration with the startup company named as Stork. They provide us with the autonomous driving packages. So that means we have to make autonomous driving decisions during the vehicle operation mechanisms. So our software will understand the environment from nearby objections or objects or collision mechanisms and then and plan ahead of it. So as you could see the different layout of the image, there are a lot of sensors on the front, behind, and also the side, especially motion sensors, lidars, and radars. And this will picturize what are the objects, and also there will be cyclists, there will be humans crossing, and there will be street light, and everything will be downgraded to 3D images and also the pixels data, so that the autonomous driving mechanism can detect everything and drive accordingly. So as a typical example, so if we are considering this image as a primary one, so as a classified output, the images will be rendered into pixel maps, and we will understand how much vehicles are lying ahead of it. So what are the obstruction for it? What are the pavements? So all of it requires that everything has to be labeled accordingly. No object should not be mislabeled or misjudged, thereby reducing the effect of autonomous driving. So we need a lot of quality control processes and also the labeling even in the parking spaces. So, coming to the autonomous parking, or let's say automatic car parking system. So Bosch has an automatic car parking system which is widely established. So what they use is short-range radars in the behind, and these labels will be designated, and they have automatic car, let's say, steering mechanisms to drop off the vehicle in terms of very easy usage. So when we talk about automation, there are different levels of automation, ranging from 0 to 5, which is the fully automated one. This is still a dream for everyone. So the first one, which is the manual control, there is no automation activities. And the second one will be that there will be some cruise control mechanism. There is automatic cruise control in many vehicles today, and this will be the level 1. And second will be level 2, partial automation, is automatic driver assistance system. This will have also the control over the steering wheels. This will provide a smart parking and other aspects, but partial, and human override is possible at any time. The level 3 and level 4 are the aim of the current automobile industry. So level 3 means it is based on conditional automation. So that means environment is detected. So just as objects that are moving, most of the driving could be performed in a highway with clear markings. And also the street signs could be detected. So the street signs will be detected by the lidars, and radar will avoid any collisions. So radar will detect what are the objects ahead of us, like humans or let's say street signs, the trees, the sideway, the pavement, and everything. So there are a lot of 3D cameras and behind side of it, which provides also additional sensing of the image quality. And the fourth level is level 4. Depending upon the driver preference, this could override the this could drive its own, but again, human supervision is still required. And level 5 is still under construction on various countries, depending upon the regulations. But this will be a dream of all the automobile manufacturers. So for the fleet management, of course, for the traffic regulations, we can designate the paths depending upon the GPS location of various vehicles and thereby routing it to according to the traffic situations. And finally, there are electric air taxis. These are based on batteries that can be used for vertically lifting the aircrafts. So there are a couple of startup companies and also established ventures for that in Europe and also in US, and some activities also there in India. So these are primarily using batteries for their propulsion activities and thereby using them as maybe like an Uber in the future for air. So as a wrap up, our future is electric. We need to revolutionize. We need to reduce the carbon footprint and also the fuel burned per car. We need to optimize the car consumption of the CO2 emission and also the fossil fuel consumption. And we need more grid activities on more charging stations for the electric vehicles. And assuming that the carbon footprint is minimum kept, because for the electric cars, when the batteries give a large amount of carbon footprint, but however, during the running process, we are not emitting any much general carbon dioxide, so the footprint is still kept at minimum. So when we compare the different industries, of course, a coal industry is a main factor that produces the carbon dioxide. Transportation is still, we are giving more innovations and reducing the carbon footprint. Industries is also a main aspect, and also residential usage also produces carbon. But these are the two factors which are in control. The industry, it is inevitable, but let's see how the world. And EU market sale, they are increasing every year, and I hope it will increase in the coming future as well. That's all from my side as a wrap up. Thank you everyone for your kind attention, and I would be happy to take any questions from your side.
Ma'am, you told that can you hear me?
Yes, I can hear you, please.
Oh, okay, you told that at 80% of the state of health, the
Mhm.
battery enters the second life.
Yes.
At what percent of SOH does it enter the third life? That is end of.
So the state of health will be about 30% when you have to reach the end of life criteria. So the first, when you have to retire from the automobile aspects, let's say from the road, it is 80%. And when you have to start recycling, it will be state of health 30%.
Okay, thank you, ma'am. My another
All right.
question is that
Mhm.
how is a V2G performing in Germany? Is it allowed over there?
Sorry, could you repeat? It was not clear.
V2G, the vehicle to grid
Yes.
system, is it allowed in Germany?
Yes, it is allowed in Germany. So here the government provides more solar system subsidies. So if we have excess energy that we could give back to the grid, and we could also provide it to the charging stations also. Yeah. So
Can we give it to the load points, V2L?
That is still under discussions because the power quality fleets are not yet optimized so much for it. Government is still not yet but in the residential phase, we could give back to the grid, but to the load one directly, not yet. Yeah. But from larger, for example, right now, the Nissan company have used their electric vehicles to power up a stadium and everything, but to the grid directly to the load, it has not been successful yet.
Okay, ma'am. Thank you, ma'am. Thank you.
All right, thanks.
I think there is a question in chat box, how to
Oh,
keep
sure.
the batteries healthier.
Ah, how to keep batteries healthier? Yeah. So I would say to operate in better conditions of the voltage, current, and also the temperature that is specified by the supplier. And do not try to overcharge. So we have a common habit, including me, sometimes we put the phone to overnight charge and we think that is okay, but it's actually very bad. So like that, you can also think about your vehicles. Overnight charging is very good in terms of slow charging, but fast charging is not. It's try to keep it limited, maybe once per week. Then our situations are okay. But everyday fast charging will also decrease the lifetime. So get rid of fast charging, slow charging for the vehicles, and do not do overnight charging for your mobile phones. Then you can keep the batteries more healthier, I would say. Yeah.
Anybody else
Excuse
with
me.
any questions? Participants can interact directly.
Excuse madam. Excuse me.
Yes,
Yeah. Am I audible, madam?
yes, yes,
Yeah.
Dr. Rao, please. Yeah.
Yeah, as compared to battery vehicle, to what is the comment on fuel cell based vehicle, madam? Because as safety precautions wise, battery vehicles, we know it affects according to the temperature also. So now some vast research is going on fuel cell based vehicles. So which is good, battery operated vehicles or fuel cell based vehicles?
I will go to the slide to explain much better. Give me a moment. So we have, of course, there are two different technologies, batteries and fuel cell. Fuel cell is based on hydrogen and fuel propulsion technology to drive the electric motors. Um, so it all depends on the consumer preference. So and also the infrastructure availability. May I say hydrogen truck systems or the fuel cell truck system, the hydrogen tank and oxygen tank can be refilled in a couple of minutes. But you could imagine when you start a drive in the highway, there are not much charging station for it or refilling station for the hydrogen tank. So that is why we have to provide longer distance for the hydrogen tanks. But the chemistry provides more range. That's one of the aspect. It provides even up to let's say 1,000 kilometers with one charge, and the battery, the infrastructure is battery powered vehicles. The infrastructure is quite developed nowadays. We have at least one charging station within 5 kilometer radius of. This is the situation in Europe. In India, it will be even more difficult, of course, but it's more coming to the range. So again, the refilling stations and refueling of hydrogen is more costly, but battery vehicles is less costly. So it all depends on the consumer who would love to have more cost, let's say more cost or less cost, depending upon that. And if we require more than 40 tons, of course, battery vehicles is not a possibility. So hydrogen trucks. So it all depends on the consumer who could pay more price and less money or so. Yeah.
One more, madam, small doubt.
Yes.
Thank you, madam. Suppose everyone is shifting towards 70% of people are shifting towards electric vehicles, then who will take care about load? Because power system is designed for the existing system. So some based on the load forecasting or whatever it may be. Suppose the electric vehicles are going on increasing, then load that will affect to the load. So the existing power system maybe carry that load or not, all that power quality issues. So for that, is there any mechanism? Is there load balancing or any power quality issues? Like you said, non-linear behaviors, harmonics.
Yes. Of course, there are. Uh, so when we have a surplus of energy from our residential systems, we could give back to the grid. So the grid has to balance, and we require a lot of analytics in that part, which I have touched up in the last session. Let me go back to the slide. Previous slide. Give me a moment, please. So here, yes, for the power quality, we have a lot of load, let's say, detecting mechanisms. And do you have any specific questions how it is being compared, or how is the mechanism in general for it?
My question is the load balancing will problem, power quality issues also.
Yes, yeah.
How we will work on that one?
We need more energy. If electric vehicles are more, of course, we need more energy sources. So that means we need more renewable sources that would give us more green electricity. However, yes, there's a limitation of the power that is generated from renewable energy sources, of course. Solar energy is good in terms of Asian conditions, and India especially fine, but in Germany, solar energy is not very much there, so we have a scarcity of it. We don't have much waterfalls, so hydroelectricity is also not an
Yes,
option.
madam. Then
So
renewable based energy charging station.
it's not an option. So we are mostly
Okay.
renewing the nuclear power plants. So we are borrowing in terms of Germany's electric condition. Most of the power comes from the outside of Germany as well. It's not a lot of waterfalls for the hydroelectric power generation, and the second would be nuclear power plants, and third is still the coal-based manufacturers are there. So the footprint is quite higher even in terms of energy. Yeah, but there are certain applications which could be which could give us more power quality deduction. I don't have the slide. Let me check the backup slides if I have some. Give me a moment. Not yet, no. So yes, we need more power in requirements, yes. So
Okay, madam. Okay.
yeah.
Thank you.
I think one question from Shainesh. In chat box, electric vehicle charging stations, if they are run by generator, then how are they sustainable?
So usually it's not run by the generator, of course, in terms of emergency with generators, yes, but in general, it will be connected to the grid, and the grid will provide energy from various power plants, whether it's nuclear, renewable energy from the wind turbines, or from solar systems. It depends on that, yeah. So not always by the generator, but in terms of if the electricity comes from renewable, then we are more sustainable. If it comes from nuclear, okay, moderate sustainability. But of course, we are in general having issues with the power grid, yes. But we need more electricity, more energy. That's never-ending demand, yeah.
Any other questions? Participants can directly ask.
Yes.
Directly interact with the speaker. Yeah.
Ma'am, in India, most of the electric manufacturers, they offer 8 years warranty for the battery.
Yes.
So does it mean that for this 8 years, the state of health will reach 80%?
So the battery warranty model it depends on the user conditions also, and the kilometers driven by the user. So they usually provide 8 years of warranty for certain kilometers. So as an example, maybe 300,000 kilometers for 5 years, something like that. So this will be the warranty condition. So in every warranty condition, you will have a kilometer, and the kilometer term comes from the driving profile of that user or the previous user, which we have the data from market. So how much acceleration is applied by the previous data analytics of the users, and this will be a forecast of the warranty condition. So yes, but
so it does not have any relation with the state of health.
It do have relation with the state of health, yes. As per the regulations, once the battery reaches 80% state of health, we have to take out that battery from the automobile and replenish it with a new battery. So if that happens within the warranty condition, of course, the manufacturer of that vehicle should provide a new set of batteries to keep up with the warranty condition. But 80% state of health should not be violated at any cost, because that is quite dangerous for the dynamic driving in road conditions. Yeah.
Okay, ma'am. Thank you, ma'am. Now, one more question is there.
Yes.
You mentioned that fast charging is not that healthy to the battery. So,
Yes.
does it mean that fast charging is a DC charging or AC charging?
Both of it. So fast
Both of them.
charging, it
Okay.
can also be DC charging and also AC charging. So usually for cars, the AC charging is most prevalent mechanism. So whether it can range from 50 kilowatt to up to 150 or 200 kilowatt. But trucks, we are aiming for 500 to 600 kilowatt hour, yeah, as a power. And there are systems in which there is dynamic charging. For example, in the highway, you have a power line, and some of the vehicles could touch the power lines with kind of like ramping mechanisms, and they will have dynamic charging over it. Yeah. So that is called as, there are many mechanisms for the charging system and many power requirements. So there are fast charging mechanism based on megawatt of powers. So this could mean that we could fast charge within like 10 minutes or so, up to 80% of the capacity of the battery.
What is the charging time for the trucks?
The charging type for the plugs, it can be CCS, it can be CHAdeMO, it could be megawatt charge plugging system. The plugging as plugs from Teslas are different. So there are not much standardized formats, but CCS and the CHAdeMO, these are standardized, but other formats are not yet standardized. But it also depends on the provider and also the manufacturer of the cars or any other vehicle, yes. But plug-in
That
is
means
the
that
most,
still
yeah.
okay. That means that portability is still absent in the EV sector. Means you cannot port from one technology to another.
Um, we are limited and our hands are tied in terms of charging, because the grid has certain capacity limitations. So we cannot go beyond, let's say, whatever the grid offers. So that means we need to stick with certain power requirements, which is most likely to less than 200 kilowatts. Yeah. For the
What
small
is a
vehicles, yeah,
yeah? Continue, ma'am.
please.
Please continue.
Yeah, please continue with the question. Yeah.
Ma'am, what is the total charging time for the trucks on an average?
So the charging time for trucks on an average is like 40 minutes to reach half of its capacity, and 1 hour to reach 80% of the capacity in a normal user scenario. Yeah. But in case of fast charging, it will be half an hour. And if we need slower charging, it will be overnight, 7 to 8 hours.
Okay, thank you, ma'am.
All right.
I
Thanks.
think one question in chat box by Dr. Madhu. To achieve carbon dioxide neutral future, will you please suggest some advanced materials that are used to construct batteries at industry level?
Advanced materials. Yes, of course. There are a lot of battery chemistries. Let me pick up the slide.
Dr. Madhu, you can also directly interact, okay?
Right. Thanks for the question. So advanced materials, of course, we need more research and development activities. But since I'm coming from academia and later to the industry, I should say, academia has a lot of activities which will be ready maybe in like a couple of years of our research with a graduate student or PhD student. But to reach the industry, it will take longer time, at least 5 to 10 years, because we need a lot of safety aspects, and also how affordable the battery is in our production, and also the cost, and how safe, and also how much materials can be purchased globally for that. So it requires more time. What are the advanced material right now is based on silicon and LMFP. So LMFP is a derivative of LFP, lithium iron phosphate. So instead of iron side, there is manganese. So these are more advancement that is coming out. And of course, there are more research activities on solid state in the US, or in general all over the world. So there are joint ventures by Volkswagen to QuantumScape, which is a solid-state battery company. So they are ramping up solid-state batteries for their ID3 vehicles, for their small electric vehicles like size of Polo or Volkswagen Golf or something like that. And there are silicon materials which could be used along with the graphite, because silicon gives more energy density. And but again, there are some disadvantages for silicon, like silicon will swell, and these activities are there in the anode, and cathode side LFP with LMFP, and also LFP will be blended with NMC, because LFP is giving more safety and NMC gives more fast charging. So a blend of it will give both of the property, and research activities are there happening more. Yeah. So a lot of advanced material researchers are there. Um, there are a lot of materials available for us, but to reach the maturity, even for the solid state batteries, there were this LMP research. This happened about 5 years, and this was started in 2021 only. So we still have some issues with the solid state batteries. So more advancement is required. Yeah.
Okay, ma'am. Am I audible now?
Yes, Dr. Madhu, please tell.
Yes, ma'am. Actually, whatever the materials you have mentioned now,
Mhm.
those materials, some of the materials actually have the issues after using of second cycle or third cycle, like battery expansion will happen due to the oxidation
Yes.
of the silica. So can
Yes.
you suggest any one material that we can avoid that expansion of the battery?
To avoid the expansion of the battery, so we could give a blend of it. So for example, silicon with a graphite. My PhD research was for silicon compounded with a graphite and carbon 65. So if we try to reduce the amount of silicon, of course, we could reduce the swelling, but we cannot avoid it. This is inevitable. That's a chemical process. Yeah.
Okay, ma'am. Thank you.
Yeah.
Ma'am.
I think one more question in chat box by Dr. B. Ravinder. Is quick charge advisable?
Quick charge, I presume you meant fast charging. Fast charging is advisable, but use it with caution, especially over 1 week of operation. Let's say a couple of times over a week is fine, but not daily. Yeah, this would be my suggestion. Yeah.
That's good. Thank you very much.
All
I'll
right.
just reply. Let's ask
Yeah.
you one more question.
Sure,
I have seen
please.
a couple of e-vehicles have been stranded because of the drained out battery.
Mm-hmm. Yes, I have seen the accidents and reports in the news. Yeah.
So really, if I did to buy that EV vehicle, will
Mhm.
there be any backup in the case of energy drain out from the battery? That's what actually I'm looking for that. See,
So,
bi-fuel mechanics is acceptable in the society.
Mhm.
I drive my vehicle with the CNG cum petrol, so I enjoy. Even one of the fuel exhaust, no problem, there is another vehicle. But in the case of battery, is there any concept or any new development that is there, if energy drains out, can I drive the car?
Mhm, mhm. So I would say we have hybrid battery vehicles. So I have a hybrid A-class actually. So I own a hybrid vehicle. So this would mean that it can drive in 2 modes. It can use petrol and it can use battery. So for hybrid vehicles, of course, the battery capacity will be lesser. So that means you have two engines, two kind of propulsion mechanism in one vehicle. So of course, you have to reduce the size of the battery that is there in the vehicle. Let me check the battery slide. Give me a moment, please. All right. So for the hybrid vehicles, this is a complete EQS, that's a complete fully powered battery electric vehicle. For the plug-in hybrid, or in general the hybrid vehicles, there are two technologies. So petrol and diesel. So you can fill up the petrol tank As an example from my own car, I can tell you. So we can fill up to 560 kilometers for the petrol and about 82 kilometers for the battery. So with the full charge. So the propulsion mechanism is that when you have the battery which is fully depleted, then only it will switch to the injection, let's say combustion engine mechanism. So similar way, there is also diesel hybrid vehicles for the trucks. For trucks, there is only exist diesel hybrid vehicles, most prominently in European market. I don't know about Indian market. So because we need a lot of diesel for it, and efficiently, petrol is much higher charge than diesel. So diesel hybrid vehicle is a solution. We have a good market in Europe and also in US. So that means that diesel will be used in case the battery runs out. And I hope this could answer your question, Dr. Ravinder. Yeah.
Yeah, thank you very much for that. I do understand.
Yes.
But I'm looking really, will there be any innovation if really the battery drains out? How to manage myself to drive the car? That's the big question.
Uh, you need to plan when you are driving with an electric vehicle. Yes. So when, for example, as an example scenario, if tomorrow I have to go to, let's say, for a conference, as an example, and if there is a 600 kilometers drive, I need to make sure that my battery is fully charged overnight. I cannot just jump into this and then start it. Maybe if the battery has 100 kilometers, I have to stop it when it reaches 80 because the safety warning will be activated and I have to stop it. Otherwise, this will go to the emergency lane by itself. Yeah, there is automatic steering control and also partial level automation. So it will go there to the emergency lane. So I have to do it. And here in Germany, if it goes to the emergency lane with low charge, you will be fined with 500 euros or something like that. Yeah. So we have to make sure if you are driving your electric vehicle, please plan accordingly. Yeah. You cannot drain out. And of course, with the new navigation systems, there will be maps that is available. That is a dynamic mapping system. So you will be redirected to with a click of button, you will be redirected to near charging station. Of course, hopefully the charging station should be free and available for us. This is still depending upon our luck. Yeah, electric vehicle infrastructure charging system has to be developed. Even now in Germany also, we still have the issues because the grid cannot provide more charging station. Yeah.
And also, I would like to bring it, I mean, I would like me have a clarification. The profile of the driver is very important. If I drive very fast, if I go at a higher speed, battery drains out very quickly.
That's for sure. Yes. Yeah. Yeah. So that, yeah. So all of the warranty and the guarantee condition that is given by European market, I'm telling about European market, they are based on the standard acceleration of, here the regulations are a bit different. 80 kilometer per hour acceleration is assumed, and we try to provide the forecast for a couple of years of usage and thereby giving a warranty condition of 5 years or 8 years. So of course, if the user violate that condition, his warranty condition will not be fulfilled. We can only comply to the terms, but if the battery drains out, it could be replaced. This is one option, and new batteries could be installed, but it's going to be a bit costly. Yes. Yeah.
Thank you very much for that.
Yeah.
Reply.
Yeah, madam, in Europe, what is the mileage of these batteries, on hybrid model, basically? How much mileage does it give for a
so
truck?
usually for a hybrid model, for a truck, diesel trucks, I think the mileage is more or less over the range of 700 to 800 kilometers. It depends on the type of the model, but mostly 100 or 200 kilometers for the battery and the rest of the kilometers by the combustion engine. So whether it be diesel or petrol, yeah. But mostly diesel hybrid models are preferred. Petrol model, very rare because customers are not interested in that. Yeah, that's the truth. Yes.
And how successful is this, EV trucks in Europe? Because in India, I went through one of recently only last month there was a seminar with
Okay,
National
very nice.
Highway Authority.
All
So
right.
they're just working on that actually, they're calculating the cost and other parameters so that they
Sure,
start
sure.
proposing.
Mhm.
So just wanted to understand, how successful is this, EV trucks in Europe?
Electric vehicle trucks in Europe is a very competitive market. First of all, there are many manufacturers. So we recently have also the manufacturers from China that is introduced here. So there is a bit of competition. Yeah, quite unfortunate to say Mercedes is in the third place. So the first place goes to the Volvo, Scania, then Mercedes, then MAN, and DAF. So the competition is very high, and unfortunately, this brand is known to be a bit more costlier. So we have a little bit less of the customers forecast for 2024. Yeah, but I hope the situation changes in 2025, and yeah, it's very competitive. Yes, in general, I should say. Yeah. But the market of electric vehicle sales also is reduced. So for example, BMW has 16% of loss, Mercedes cars has 14%, and Volkswagen is trying to shut down 3 of the companies. And situation in Germany in general is it's quite low. It's slow and bleak situation. Yeah. So we are hoping it will change in the next years as inflation and market will improve. Yeah.
And madam, what is the ROI basically, for EV trucks basically?
For the return
Normally,
of investments or
yeah, ROI, return on investment, EV
Uh,
trucks. If you provide.
oh, so most of the EV trucks which we have is based on leasing models. So leasing is one of the aspects that we provide, and customers are more attracted to that because, of course, when you say leasing, that means battery ownership of it will be with Mercedes, and they could replace the batteries once it reaches the warranty condition for a certain cost. So in that case, the return of investment is very higher. But in case of first-hand use, the return investment will be lesser because second-hand market is still very good in truck side, but in the car side, it's not very good for electric cars. So it is when it is leasing, the return investment is quite higher. Customers are more happier, but with single usage, first-hand use, they are not so pretty nice for the second-hand market. Yeah.
And is battery swapping also possible with EV trucks, like in between?
Swapping is not yet achieved in EV trucks, but for electric scooters, the small ones, I
Yeah,
hope it's also there.
yeah, it's there, but
It's
for
there, but
EV, yes.
mm, for bigger trucks, we don't have swapping. If the truck batteries has to be replaced, it has to be come to the workshop, manually replaced. There is no swapping activities that could be done by the customers. But we could, the only thing we provide is the forecast the batteries are about to die or it has to be repaired and warranty conditions and the repair, let's say safety mechanisms. But other than that, we don't have any swapping, not yet established.
And madam, one more question, like
Yes.
solid state batteries, which you have said that, now it cannot be implemented because of certain factors. But I was going through one of the article which was saying that after 2030, the complete lithium ion batteries will be replaced by
Mhm,
solid state batteries.
mhm,
So
mhm.
what is actually the truth?
Solid state batteries, so Volkswagen had a collaboration with some of the solid state battery companies like QuantumScape and all in US, but the safety mechanisms of it, it's still it's still not yet completely commercialized. So when you say the market maturity is that solid state batteries are more expensive than normal lithium ion batteries. So that means the industry has to give for a cost disparity, right? So it has not reached the market maturity in terms of the safety and also the energy density, I would say. So that is why it's still low. Maybe in 5 to 10 years, it will come up, but it needs more research and development activities, I should say.
And
And
madam,
yes,
one question regarding the recycling, recycling
yeah.
of lithium ion cell basically. So how profitable is this business? It's like in terms like in India, it's in a very nascent stage, So industries are looking into setting up recycling plants basically.
Yes.
So is it because until unless there is no profit, corporates are not coming up and setting up plants.
Yeah, in India, the market in general, only reading my knowledge. The market now is 2 to 3% is electric vehicle market, and government
Right.
want to increase to 30% by 2035
Yeah,
or
they come up with
2040.
FAME policies, FAME 4.
Exactly. So after that time, maybe in 5 years or so, there will be a challenge for the manufacturers and also the customers what to do with these batteries. So until that time, I guess it will be an uncertain situation. But profitability means of material extraction, I should say, it's not yet up to because the energy that is required to dismantle and extract that battery materials out of it is not the return of investment is not in profitable range until now. But this is happening in a smaller scale in Germany as well, but there is not much large scale recycling plants. And from Volkswagen, there are some for BMW for refurbishing and let's say, but not much into the recycling aspect. For Mercedes also, there is a small sister brand for recycling, but it's not yet in the profitable terms once I have seen the metrics. Yeah. Yes. So, yeah.
Thank you so much for the insights.
All right. Thanks to Dr. Santosh. Yeah. All right. If there are any questions, please write to me. And I assume that our time is limited. Yeah.
Yeah, I think participants can surely contact, or if next speaker has not joined, still participants can ask 1 or 2 questions.
I have
Oh,
joined, by the way.
sorry. Okay, sorry, sir. I didn't see you. Sorry.